It's one of the most rugged and confused mountain regions on Earth. It consists of a jumble of snow-covered peaks, between which lie deep valleys with precipitous slopes. It's called Fiordland. With 3 million acres, it's one of the largest national parks in the world. The valleys hide many natural wonders: rivers, caves, huge waterfalls, dry woodlands and rainforests. Until quite recently, the mountains of Fiordland also hid this strange creature. In 1948, a New Zealand doctor, Geoffrey Orbell, made an amazing discovery among his native mountains. A bird was living there, which all the experts had said had been extinct for over 50 years. The discovery Dr. Orbell made in the Murchison Mountains of Fiordland was a surviving colony of Notornis mantelli, a large flightless bird which the Maoris christened the takahe. Perhaps it isn't surprising that the takahe had managed to keep itself secret for so long. You have only to look at the nature of the mountain wilderness in which it lives. The takahe had another ally in its bid for anonymity: the weather. Clouds often obscure the peaks and alpine meadows with alarming suddenness. And in Fiordland, it rains as it rains in few other places on Earth. It's small wonder that the peaks of Fiordland are often known as the Mountains of Water. Fiordland lies close to one of the Earth's major fault lines at the southwest end of South Island, New Zealand. It's barely 125 miles long by 40 wide. It's bounded to the east by Lake Te Anau and on the west by the Tasman Sea. It's quite unlike any other part of New Zealand. Its scenery is so wild that it looks as though it might be more at home in coastal Norway. Captain Cook in the Endeavour was the first European to set eyes on these fjords in 1770. But he didn't land there until his second voyage in the Resolution, 3 years later. Some idea of how small Cook must have felt in his tiny ship is given by this shot of the QE2, the world's largest liner, cruising in Milford Sound. The exploration of the interior of Fiordland didn't begin until 150 years later. And it wasn't until the 1880s that the explorers really got underway, pioneering routes from the Great Lake Te Anau in the east, up over the passes to the west coast. Many of the peaks and valleys bear the names of pioneers or names that reminded the first settlers of home. The Holyford Valley recalled memories of a part of Ireland. The exploration of Fiordland was not without cost. Having climbed the terrifying cliff over which tumbles the Sutherland Falls, William Quill was later killed exploring a new route to the west. The lake which feeds the Sutherland Falls bears the explorer's name, Lake Quill. The falls, one of the highest in the world, drop just under 2,000 feet in 3 huge leaps. Once you've glimpsed the tortured topography of Fiordland, the question uppermost in your mind is, how did this extraordinary maze of peaks, fjords and valleys get to be the way it is today? It's a complicated story. Fiordland has been a mountainous region for around 400 million years. It has literally had its ups and downs. This is what it looked like about 300 million years ago, in the Carboniferous period. About 250 million years later, erosion had worn the previous mountains down to a sort of low tundra, exposing some of the hard basement rocks. This build-up and wear-down has happened at least 3 times in Fiordland's geological history. That's a tuatara, a small relative of the dinosaurs that is still around today. Fiordland lies along the Alpine fault system, one of the Earth's moving plates. Plate movement in the last 65 million years has pushed up the present mountains. To complicate things further, Fiordland itself has been moving on this plate relative to the rest of South Island. The Ice Age, which began about 300,000 years ago and retreated during the last 14,000 years, filled the valleys so that only the peaks showed. Melting ice raised the sea level and filled some of the newly deepened valleys, flooding them to form the fjords which give the land its present name. There's another element that makes Fiordland what it is and shapes the lifestyle of every living thing there, and that's the weather. In Fiordland, you can rely on it raining for up to 200 days out of every 365. The wettest place of all, Milford Sound on the west coast, has 20 feet of rain a year. If you can rely on the rainfall, you can also rely on the direction from which it comes. The weather system is strictly one way, from west to east. It never changes, and it works this way. The weather comes in off the Tasman Sea, loaded with moisture. It drops its first heavy load of rain when it meets land on the west coast. Then the wind pushes it inland to climb up over the foothills and valleys. There it deposits rainfall number 2. The clouds rise to cross the high peaks. There they shed most of their remaining water as snow. This consistent weather pattern creates the many habitats of Fiordland and dictates what sort of creatures live in them. Rain clouds approach the west coast from the Tasman Sea. The always prevailing westerlies propel them inland. The first heavy rainfall occurs as the warm, moist air lifts above the coast. The recipient in this case is Martin's Bay on the north coast of Fiordland. Martin's Bay is slightly warmer than the Fiordland coast to the south, but its rainfall is the same. That's to say, torrential. In each area, excessive rainfall produces a different type of environment. One of the strangest of all is this tangled mass of roots on the coast at Martin's Bay. The local name is kiki. It belongs to the screw pine family. There are 50 species. The kiki is native to New Zealand. To a human, it is practically impenetrable. It's hard to cut and impossible to walk through. The kiki and the flax that grows close by provide nesting grounds for one of Fiordland's unique bird species. This horticultural obstacle course is no barrier to the Fiordland crested penguin. It's one of the smaller penguins, standing just over 2 feet high. Several penguin species have similar yellow crests. This one is easy to identify. Fiordland is the only place in the world where it nests. There are only 15,000 Fiordland crested penguins in the world. This isn't a great number when they have a disastrous breeding season, as they did recently. There were dead chicks everywhere. Wet and muddy, the casualties look almost as if they've been oiled, but they're too young to have been to sea yet. The most likely explanation is that they were attacked by an unknown virus. The adults were unaffected. Fortunately, some chicks were raised successfully. Scientists from the Conservation Department are trying to isolate the cause. Could it have been in food caught by the parents at sea? The calamity may have been a natural one that has occurred many times before. But with threats to penguin species increasing in all the southern oceans, no chances can be taken. No such problem affects another unique New Zealand species, the black teal, more accurately called the New Zealand scaup. The rocks close by the tangled kiki roots provide the hen with ideal nesting sites. While the hens incubate on their down-filled nests, the male scaup gather in small flocks close by. When the females leave the nest, the males escort them back. The heavy rainfall at the coast produces the beautiful as well as the grotesque. Close by the maze of kiki roots grow thickets of kohai trees. They're the first trees to come into flower early in New Zealand spring. That's September down there. Their blossoms are rich in nectar. Birds like the tui are quick to take advantage of the harvest. The tui has a brush-like tongue, well adapted to collecting nectar. It also has a beautiful and varied repertoire of song. The tui is not completely selective in its feeding. When a bee comes in range, the tui samples it, but decides it isn't good to eat. In the moist salt air of the coast, only the most resilient grasses survive. Down in the wiry stems of the cutty grass nests another rare New Zealander, the fernbird. It looks like a large lark. It's a swamp and reed dweller. Its feathers lack the connecting barbs which hold most birds' feathers together, so it's a poor flyer. In the past, this has probably been no great disadvantage. For millions of years, New Zealand had no mammals to prey on ground-nesting birds. The settlers changed all that by introducing rats and stoats, not to mention domestic cats and dogs. The fernbird's best defenses are its secretive ways. It hides its nest well down in the reed stems, and it raises 2 broods a year. The first rain has fallen at the coast to produce the weird and varied vegetation found at Martin's Bay. The west wind pushes the weather system onto its next unloading point, where the valleys rise up towards the mountains. A cloudless day allows a good view of the forest below. It looks almost like an English oak wood. An English oak or beechwood seldom has to put up with the kind of weather that frequently assails this forest. The moss draped on the trees proclaims that this is very wet woodland indeed. Some of the woods this rainfall creates can accurately be described as rainforest. The tall trees are a mixture of silver beech, evergreen podocarps, and rimu, or red pine. Beneath them grows a ground cover of tropical intensity, with many species of fern, including ancient tree ferns that have changed little since the days of the dinosaurs. Though a great deal of New Zealand's native woodland has been felled to make way for faster-growing commercial timber, the forests of Fiordland are safe inside the national park. In the past, even these have suffered damage from introduced deer, but deer numbers have been drastically reduced. So now you're looking at the wet beech forest much as the early Maori invaders saw it. In spring, these moist beechwoods provide nesting cover for many of New Zealand's small birds. This flittering progress through the branches is that of a grey warbler approaching its nest. The nest is a pear-shaped affair, hanging from one slender twig. It's built entirely by the female, though the male does give a hand by bringing in nesting material. The entrance is hooded against predators, including the New Zealand shining cuckoo, which is very partial to laying its own eggs in grey warblers' nests. The female enters to brood her clutch of 4 eggs. South Island tomtits usually nest in holes in trees or rock crevices. Perhaps because it feels that the thick canopy of the moist beechwood gives protection enough, this one has built out in the open, on a branch. That's the male nearby. Tomtits are not particular about what kind of forest they inhabit. Recently, their numbers have fallen severely as the result of forest clearing and replacing with quick-growing conifers. Sadly, it's an all too familiar story in New Zealand. The male selects the nest site, but it's the female who builds the nest from moss, spiders' webs, and feathers. The wet beechwoods have one great advantage: a superabundance of insects on which to feed the young when they hatch. The torrential rainfall creates lowland forest, which often looks more suited to the Amazon basin. The next stop for Fiordland's west to east weather system is in the high peaks, where the rain will turn to snow. The rain clouds that originated over the Tasman Sea move on eastward and lift to cross the peaks of Fiordland. The highest mountains reach 8,000 feet, and there the clouds drop their remaining moisture as snow. Not much lives here above the tree line, and certainly not in the winter. But in the alpine meadows and more sheltered high-altitude valleys, the weather system creates yet another Fiordland habitat. One bird that is at home on the edge of the snowline is New Zealand's mountain parrot, the kea. It's a large, inquisitive bird with a harsh cry from which it takes its name. Its feeding range is wide. The hooked beak is ideal for tearing apart the tough subalpine vegetation. It also has a taste for anything from camera lenses to knives and forks, as many trekkers camping in Fiordland have found to their cost. In spring and summer, rock wrens shelter in the subalpine scrub. They always seem to avoid the sun. In spring, the mountain slopes and meadows are rich in flowering plants. A track through the snow tussock grass reveals the presence of one of the world's rarest birds. So far, it's only found in one small area of Fiordland, the Murchison Mountains. It was here, in 1948, that Dr. Geoffrey Orbell rediscovered the bird that had last been sighted in 1898. The early ancestors of Notornis, commonly called the takahe, flew to New Zealand millions of years ago. Finding no mammal predators, they eventually became flightless, like the kiwi and several other New Zealand species. For most of the year, the takahe lives above the tree line, feeding and nesting among the snow tussock grass. The takahe depends entirely for its survival on a handful of plants, mainly 3 species of snow tussock. Unfortunately, introduced red deer destroyed large areas of this vital food. The takahe is a very selective feeder. It samples its food, this is daggerleaf daisy, until it finds a plant rich in nutriment. It pulls up a shoot, holds it in a claw, and nips off the base, the most nourishing part, with its powerful beak. Takahe start to breed when the snow clears in October. Both adults share the nesting and rearing chores. The nest is usually well hidden under a bar of snow tussock. She's laid 2 eggs and takes turns during the 30-day incubation period with her mate. Here's the changeover. Invariably, when coming off duty, these birds went to have a drink and a bath. When Dr. Orbell rediscovered the takahe, there were probably fewer than 50 birds left. Numbers fell further in the 1950s. Predation by introduced stoats was one of the causes. But the loss of habitat where the introduced red deer ate the takahe's food plants was the main reason. Now, deer numbers have been greatly reduced. Takahe build several trial nests before the final one in which the eggs are laid. One theory is that this helps to synchronize the peak of the male and female's breeding cycle. Today, there are about 180 birds in the wild. And as we'll see, the Conservation Department is successfully increasing their numbers, and not only in the Murchison Mountains. The weather has shed most of its moisture by the time the westerlies have propelled it across the peaks. The air that flows down the eastern slopes of Fiordland is dry by comparison. Once again, this creates a different kind of woodland. The forests that cover the hillsides leading down to the Great Lake Te Anau, the eastern boundary of Fiordland, are quite unlike those of the west side of the mountains. Though moss covers the fallen tree trunks, there's none of that luxuriant trailing green beard-like growth. That belongs to the wet beechwoods on the other side of the range. There are few ferns, and certainly no tree ferns. These are dry beechwoods. The predominant tree here is the mountain beech, favoured by the drier climate. As you'd expect, the birds are different too. A strange place to find a falcon. They're usually birds of the open spaces. But the kestrel-sized New Zealand falcon prefers to nest on the edge of these forests. There's no shortage of small birds as prey for the falcon. The South Island robin, for one. It prefers the dry woodland, feeding largely on the forest floor. Another bird exclusive to South Island, the yellowhead, is at home here too. It feeds rather like a tree creeper, gripping the trunk with its claws and fanning out its tail. They wear down their tail feathers in doing so, until they look like little spines. Yellowheads live almost entirely on insects and spiders. The yellow-crowned parakeet feeds in the canopy of the dry beechwoods. Buds, flowers, shoots, insects. Almost any food is welcome. Beneath this fallen beech, there's a well-hidden nest. It belongs to a bird at home in any type of forest. Fantails are one of New Zealand's most prolific species. They can rear up to 5 broods a year, each one in a different nest. Both birds build the first nest. After that, he often leaves it to her to do the home building. He's too busy feeding the fledglings from the previous brood. This is the first nest of the season. When the chicks hatch out, she does most of the brooding while the male catches insects to feed the family. That's the one part of the rearing process he never shirks, no matter whether this is the first or even the 5th nest. This nest belongs to a silver-eye. It's an adaptable little bird found throughout New Zealand. The drier beech forests suit its lifestyle very well. They provide everything it needs during the breeding season. She has 2 chicks, a few days old, which both parents feed, mainly on insects. None of Fiordland's habitats would be complete without a weka. The weka is an all-round predator. It even takes takahe eggs high up in the alpine meadows. Despite that rudimentary wing, wekas can't fly. So tree-nesting birds are safe from them until their young start hopping around on the forest floor. There, anything edible is fair game to the weka. No small bird, young or old, is safe from the noblest hunter of the dry beechwoods, the New Zealand falcon. The falcon has its own young to provide for. The nest is not at all the sort of place you'd expect to find a falcon's eyrie. It's under a fallen tree. The falcon has caught a tomtit and is plucking it before delivering it to its two well-grown young. This young falcon is 3 weeks old and well able to tear the prey apart for itself. From now on, the parents will bring in half a dozen small birds a day to feed their fast-growing young. High in the beechwoods, above Lake Te Anau, there's a deep cleft in the foothills of the Murchison Mountains. The cleft was made by Tunnel Burn, a stream which has long since gone underground. Tunnel Burn drains Lake Orbell in Takahe Valley. Over the past 30,000 years, the underground river has carved out a spectacular cave system. The story is still one of the effect of rainfall on the many landscapes of Fiordland. This time, the habitat created is totally different from all the rest, as is the weird creature that has made the caves its home. As you'd expect in limestone caves of this age, the water has created a display of stalactites and stalagmites. Stalactites are produced by water rich in limestone, constantly dripping from the ceiling. These luminous strings of pearls are the work of a living creature. A stalactite grows in these caves at the rate of 2 inches every 350 years. This strange cluster of jewels was completed in a couple of hours. And here's the animal that made these shining ornaments. It's known locally as a glowworm. It's really the larva of a small 2-winged fly, a member of the family of fungus gnats, only it doesn't feed on fungus. Arachnocampa luminosa. The second half of its scientific name gives a clue to the way it catches its prey. Its illumination entices its victims towards the hanging strings of beads. What's more, they're sticky. The larva builds itself a nest of silk and mucus on the cave roof. Inside this, it moves about by muscular contractions of its body. Caves are the ideal environment for the glowworm larva. To succeed, it needs 5 things: a humid atmosphere, otherwise the lava would dry out. A ceiling from which to hang its fishing lines. Lack of wind to prevent the lines from becoming entangled. A good supply of flying insects for food, and darkness in which the larvae can glow. How do they make these fishing lines? Both silk and sticky mucus are extruded from a gland near the head. The head is withdrawn into the body and a blob of glue released at intervals onto the silk and then lowered. The larvae can not only switch their lamps on and off, they can reflect the light, which is at the tail end, downwards towards the fishing lines. The blobs of glue are so clear that some act as tiny lenses. This one reflects the pattern of the rocks behind it. Looking upwards in the darkness, the insect victim sees the glowworms as a mass of bright stars in the sky. It's attracted by this false star glow and flies upwards. It's even said that the hungrier the glowworm, the brighter it can make its light shine. Here's one insect, a small moth, that navigated by that false starlight with fatal results. When the larva senses a catch, it crawls down the appropriate line and grabs it in its jaws. It pulls it up and hooks the spare line onto bristles on its back. As it does so, it hauls itself back into the nest. Once in the nest, it paralyzes its prey with a bite. Only the larval stage of the glowworm needs to eat. The adult flies are purely breeding machines. They have no mouth or stomach and only live a few days. That's the male on the right. The female is already swollen with eggs when she emerges from the pupa. The male immediately fertilizes them. The empty pupa case hangs from the cave roof, close to the cluster of eggs she laid soon after mating. Outside the cave, 10 miles beyond the point at which tunnel burn goes underground, is the area in the Murchison Mountains where the Takahe was rediscovered. Because of the bird's rarity, the alpine meadows beyond the cleft in the hills are perhaps the most vital habitat that Fiordland's unique weather system creates. Certainly, the one most in need of protection. There, the Department of Conservation is doing everything possible to increase the Takahe's slender hold on the wild. A conservation officer carefully approaches a Takahe nest. He takes an egg from under the sitting hen. She's laid 2. He'll repeat the process with the second egg later. The bird moves off a short distance and stands, remarkably calmly, while he weighs the egg. As he measures it, she even feeds, only about 20 yards away. The most important thing is to find out if both eggs are fertile. He does this by candling, holding each egg up against a bright torch inside a black bag. If they're both fertile, one will be flown back to be hatched out in an incubator at Burwood Rearing Station. The other will be left to hatch out naturally. Until very recently, attempts to rear takahe artificially were largely unsuccessful, partly because of the difficulty of finding the right diet for the chicks. Now that problem has been solved. The egg is packed in a foam-filled rubber container for its helicopter flight back to Burwood. Three weeks later, at Burwood Station, the egg is ready to hatch. In the incubator, the chick inside is beginning to chip its shell. Tape recordings of a sitting hen bird are played to encourage it to emerge. It's put under a brooder that looks just like mother. Heat is provided by an electric blanket. The successful diet that has been worked out for the chicks consists of a mixture of clover, cabbage, carrot, potato, vegetable oil and Ferex. It's important that the chicks don't see a person at this stage, lest they become too dependent on humans, a process known as imprinting. That's why they're fed with a dummy takahe beak. After many early failures, rearing one of the world's rarest birds has become almost routine. It's vital to know how the young birds fare and how far they wander once they're released in the mountains. This is the first time hand-reared takahe have been put back into the wild. These are last year's hatch. They're 1 year old. To check on their progress and even survival, tiny radio transmitters are fitted. The attachment of the radio causes the bird no distress. It will give a signal that can be picked up 2 miles away, and its battery will keep it on the air for up to 6 months. The receiver is checked, and this bird is now ready to start transmitting. The Conservation Department is anxious to re-establish the takahe in other parts of its original range. These reared birds are destined for the Stewart Mountains. The habitat is similar to the Murchisons, from which the eggs were originally taken. The Stewarts lie 30 miles to the north of the Murchison Range. The helicopter lands close to a wire pen into which the takahe will be put until they've settled. It looks inhospitable country, but takahe can easily climb rocky slopes like these to reach food in the next valley. The cloud is beginning to creep into the valley. It's time to be going. The weather can quickly close in, even when the sky everywhere else appears quite clear. A month later, the chopper returns. Its mission: to trace the released birds by the signals from their miniature radios. Each bird transmits on a different frequency. All 8 birds are eventually found close to the release area. So there's a good chance that the secret the mountains of water hid for so long is now safe. And as a recently created World Heritage Site, the same mercifully can be said for Fiordland itself.